RG, I just have one question about the kind of practical implementation of this in terms of, for an average review author, in terms of selecting multiple methods for estimating the between study variance and potentially the confidence interval. Obviously, there are a lot of sensitivity analyses that you could potentially undertake. Do you have any thoughts about what you might prioritise in terms of those sensitivity analyses?
Yeah, that is a great question, and this is actually what we need to consider in practice. I would certainly start with the default option, since this is what we usually do, and we cannot really change what is already out there. But then I would see the robustness of the results using a different approach, like the restricted maximum likelihood, for example, for the between study variance estimators, or also using the Poland-Mandel estimator. Those are available not only in Stata, but also in R, using several packages, like, for example, the Metaphor package in R, or the Meta package in R. So since there are options in software that we can use very easily, I would try to see the robustness of the results. And similarly for the confidence interval methods for the overall effect size, I would probably try the wall type method first, and then see how the results change, if they change, using the Hartog-Knapp-Sedding-Jonkman approach, or even the profile likelihood approach.
Thanks for that, RG. And I think this question that's come through is related to that, really. So Michelle Hilton-Boone has thanked you for a fascinating presentation. And she has asked, do you envisage producing a decision algorithm or flow diagram to support reviewers in choosing the methods? Or perhaps this is already available.
First of all, thank you so much for your kind words, and thank you so much for joining this a webinar. That would be a great process to provide a flow diagram to show which method is the best for which case. So far there is no such a diagram, but we need to consider that many of these estimators and methods have different properties. So as we saw, there are different properties for small heterogeneity, small number of studies, and large number of studies. So these are properties that we have to consider, absolutely. And maybe in the future we should provide such a diagram to help reviewers. So far, as far as I know, no, this is not available.
Okay, we have another.
Sorry, if I could add, the main issue is when we have only a few number of studies in the meta-analysis, when we have only 2 or 3 studies. So in these cases, I believe whichever method we try to use, the estimation of heterogeneity is not really will not be a good estimation because of the small number of studies. We don't have enough data, so that's, I believe, the problem.
Okay, and perhaps related to that is a question which says, how do we judge whether the prior information is appropriate or not? I assume that's potentially prior information for your between study variance.
Right. So for the between study variance, there are empirical. The Turner et al. And Rhodes et al. Have published the empirical distribution for heterogeneity when we have dichotomous data and continuous data. So since these heterogeneity distributions are available, I believe this would be a valid prior to use in your meta-analysis, according to the outcome category and the comparison type that the authors have used.
Okay, it doesn't look like we've got any further questions coming through. One question, which is, again, thinking about the reviews that are already available on the Cochrane Library, and in terms of Do you think it would be only appropriate when they updated those reviews that the methods would presumably change at that point to what might be the new recommended defaults?
That's a great question. So when we update a Cochrane review, I believe we could use that's why I said previously we could use the default option, the Dirsimon and Laird, let's say, for the between study variance, and then also use another estimator to assess the robustness of the results. So let's try to avoid the mistakes, if these are mistakes. Maybe they are not, but let's try to avoid that in the future and try to involve more appropriate methods in the updates of the Cochrane reviews. But certainly I would suggest conducting a sensitivity analysis, because the major problem in Cochrane reviews is that we have only a few number of studies in the meta-analysis.
Excellent. And a related question to that, of course, so I think the Davey study only found a median of three studies included in meta-analyses and Cochrane reviews. And so the questions come through, which is, if there are only a few studies, should we just discourage the use of the random effects model altogether?
Discourage the random effects? No, I wouldn't say that. Unless there are any other issues, for example, unless there is publication bias or other issues that we need to consider alternative models, but I wouldn't discourage the random effects because of that. We need to account for the heterogeneity in our results, but we need to account this properly. Not accounting for that would be, in my opinion, that would not be valid. That would be probably a mistake.
But the question, I guess, is around if you've only got very few studies included in the meta-analysis.
Oh, I see. Sorry, I probably misinterpreted the question. So if we have only 2 or 3 studies, and using the fixed effects, for example, model, I think that a simulation study or an empirical study for the Cochrane reviews by Contopadeli showed that the Dirsimon and Laird, in these cases, mostly estimate heterogeneity equal to 0. So it would be as if we used the fixed effect model. I'm very confused with that. I'm not sure if I should say yes, we should use a fixed effect or a random effects model, but certainly what I believe would be best is to incorporate heterogeneity, even if we cannot really observe this. And certainly if we can use the prior information, for example, the prior distributions that were found by Turner et al. And Rhodes et al., that would be probably the best approach in a Bayesian framework, though.
Yes, and I think there's one last question here, and this might be going beyond what you want to answer, RG, I realise this, but this question is really relating to grade. So if the sensitivity analyses detect differences between the estimation methods that you're using, how should you include these findings in the grade assessment in terms of assessing the certainty of the evidence? So do you have any ideas about how you might do that?
No, I wouldn't downgrade for using a different heterogeneity estimator. I wouldn't downgrade this in grade. I'm not sure if this should first, at this point, should be included in grade. I don't think so. But because there is no certain method so far that we need to use at each case. So more simulations I believe, are needed to clarify this picture. And once this is better clarified, maybe we could add this in grade. But at this point, no, I wouldn't add that.